You know that feeling when something is missing, but you can't quite figure out what it is? Like walking into your apartment and sensing that something's been moved, but every piece of furniture is exactly where it should be. That's what it felt like when I stepped out onto my balcony that night. It was around 11. I had a cup of coffee in my hand, and I just wanted a few minutes of quiet before going to bed. I looked up, the way you do without thinking, and the sky looked wrong. Not dramatically wrong, not like a disaster movie, just empty, too dark, too flat, like someone had taken a photo of the night and removed one layer in Photoshop. It took me a solid 30 seconds to understand what I was looking at, or rather, what I wasn't looking at. The moon was gone. Not hidden behind a cloud, not blocked by a building, just gone. A sky full of stars, and a hole where the most familiar object in human history used to be. I want you to pause for a second and actually think about that. The moon has been up there for 4.5 billion years. It was there before the first fish crawled onto land. It was there before the dinosaurs, before the ice ages, before the first human looked up and wondered what that glowing disk was. And now, on a random Tuesday night, it's not there anymore. My first instinct was honestly kind of stupid. I pulled out my phone and opened a weather app, as if the moon disappearing was some kind of forecast I had missed. Partly cloudy, 11 degrees, no mention of the moon vanishing from existence. So I did what everyone does when reality stops making sense. I went to Twitter, and that's when I realized it wasn't just me. The feed was already on fire. Hundreds of posts per second. People from Tokyo, from Sao Paulo, from Lagos, all saying the same thing. Where is the moon? Some people were joking. Most were not. Within minutes, NASA's account posted a single line confirming that the moon was no longer detectable in its expected orbital position. No explanation, no reassurance, just a fact, sitting there like a brick on a white tablecloth. I remember looking back up at the sky, and this time I really saw it. Without the moon, the night was darker than anything I had ever experienced in a city. Not just darker, different. The stars were sharper. I could see the Milky Way from my balcony, which I had never been able to do before. Not once in 15 years of living in this apartment. That faint band of light stretching across the sky, usually washed out by the moon's glow and the city lights, was suddenly right there, impossibly detailed, like someone had cranked up the resolution on the universe. And here's the thing that nobody tells you about the moon. It is bright. Genuinely, absurdly bright. A full moon puts out about 0.2 lux of illumination on the ground. That doesn't sound like a lot until you realize that a new moon gives you 0.002 lux. That's a 100-fold difference. Enough to walk outside without a flashlight. Enough to see a face across a field. Enough to read large print if your eyes are adjusted. Without that light, the world outside of street lamp range was now pitch black. Not romantic darkness, not cinematic darkness, the kind of darkness where you cannot see your own hand. I stood there for maybe 20 minutes just staring at the sky. And then I noticed something I wish I could unhear. The city had gone quiet. Not silent. There were still cars, still distant sirens. But the usual background noise had shifted. Dogs were barking. Not one or two. Dozens of them across the neighborhood. A rolling wave of confused, anxious barking that wouldn't stop. And then I heard the birds. You don't expect to hear birds at midnight, but there they were. Not singing, calling. Short, sharp, panicked calls from species that should have been deep asleep. I found out later that this was happening everywhere. Across the entire planet, in the span of about 2 hours, nocturnal ecosystems basically short-circuited. See, the moon isn't just a light in the sky, it's a clock. A biological clock that hundreds of species have evolved around for hundreds of millions of years. Coral reefs time their mass spawning events to the full moon. They release billions of eggs and sperm into the water simultaneously, and the trigger is moonlight hitting the water at a specific intensity. Without that signal, the synchronization breaks. Some corals spawn, most don't. The ones that do release their gametes into water where there aren't enough partners. Reproduction rates collapse. And it's not just corals. Dung beetles navigate by the polarized light of the moon. Actual research, published in Current Biology, showed that dung beetles roll their dung balls in straight lines by using the moon as a compass. Without it, they roll in circles. Barn owls hunt more effectively under moonlight. Their prey, small rodents, know this, so mice and voles avoid open ground on bright nights. They've evolved to fear the moon. Without it, the entire predator-prey balance of nocturnal grasslands shifts overnight. If you're finding this interesting, by the way, I'd really appreciate it if you hit that subscribe button. I spent weeks researching this, and more subscribers means I get to keep making stuff like this. All right, back to the end of the world. Migratory birds were the ones I heard from my balcony that night. Many species, including the Eurasian skylark, actually prefer to migrate on bright moonlit nights. Research published in scientific journals found that their migration activity increases significantly with moonlight intensity. These birds use the moon for navigation, for judging altitude, for staying oriented on journeys that span continents. Without the moon, millions of birds in mid-migration suddenly lost one of their primary navigation tools. Imagine driving on a highway at night, and every road sign disappears at once. But all of that, the birds, the beetles, the corals, all of that was the small stuff. The biological chaos, the tremor before the earthquake. Because while I was standing on my balcony listening to confused sparrows, something much bigger was already happening. 300 miles away, on every coastline on Earth. The tides were wrong. To understand why, you need to know one number. The moon's gravitational pull is responsible for roughly 2/3 of Earth's tidal forces. The sun handles the other third. When the moon vanished, 2/3 of the engine driving every ocean tide on the planet just switched off. Not gradually, instantly. Now, water doesn't just stop. The oceans were already in motion. Billions of tons of water that had been pulled into tidal bulges by the moon's gravity were suddenly released. In some places, the tide that was coming in just stopped and then started going back out, slowly, weirdly, at the wrong time. In other places, harbors that should have been at low tide were still holding water that had nowhere to go. The rhythm was broken. Within the first hour, coastal monitoring stations around the world started flagging anomalies. Tide gauges in places like the Bay of Fundy, which normally sees tidal swings of up to 16 meters, recorded a swing of roughly 5 meters. Still significant because that's the sun's contribution. But for a bay whose entire ecosystem, infrastructure, and economy was built around 16-meter tides, a drop to 5 meters is like someone turning off the gravity in one room of your house. Everything that was designed for that force suddenly doesn't work. I didn't sleep that night. I don't think many people did. I sat on my couch refreshing news feeds, watching scientists try to explain something that had no explanation. The moon didn't drift away. It didn't explode. There was no debris, no radiation spike, no gravitational wave. It was simply there, and then it wasn't. Every telescope on Earth and in orbit confirmed the same thing. The space where the moon had been was empty. By 3 in the morning, someone had pulled together a live feed of the ocean from a coastal camera in Portugal. I watched it for an hour. The waves looked normal, but the waterline was wrong. It was sitting at a height that made no sense for that time of night. The comments were full of fishermen saying they'd never seen anything like it. One of them wrote something that stuck with me. He said the ocean looked like it had forgotten what it was supposed to do, and that's exactly what it felt like. The whole planet, in the span of a few hours, had forgotten its rhythm. The tides, the light, the animals, the sky itself. Everything that had been quietly synchronized by this one object for billions of years was now out of sync. And we were only a few hours in. The sun came up the next morning, right on schedule. That was almost the strangest part. Everything about the day looked completely normal. Blue sky, warm light, people going to work. You could almost convince yourself it had been a dream. Until you looked at your phone and saw the headlines. Until you talked to someone and saw the look in their eyes. That specific look people get when something fundamental has changed and they haven't processed it yet. But the daylight was hiding something. Because while we were all going about our Tuesday, trying to figure out what this meant for mortgages and school schedules and whether the stock market would open, the ocean was quietly rearranging itself. And what it was building toward was something that no one, not even the scientists who had spent their careers studying tides, had fully thought through. Because tides aren't just water going up and down. Tides are the engine that drives ocean currents, and ocean currents are the thermostat of the planet. And someone had just ripped out 2/3 of the thermostat. The first week was when it stopped feeling like a news story and started feeling like a new reality. By day 3, every major fishing port on the Atlantic coast had reported the same thing. The catch was wrong. Not gone, not yet, but wrong. Fish were showing up in places they shouldn't be, at depths they don't usually occupy, in numbers that didn't match any pattern the fishermen had seen in their lifetimes. And in some of the most productive fishing grounds on Earth, the nets were coming up light. Here's why. Tidal currents do something that most people never think about. They stir the ocean. When the tide comes in and goes out, it creates vertical mixing. Cold, nutrient-rich water from the deep gets pulled up toward the surface, where sunlight can reach it. That's where phytoplankton live. Phytoplankton are microscopic organisms that produce roughly half of all the oxygen on Earth. Half. Not from rainforests, not from grasslands. From tiny organisms floating in the top layer of the ocean, feeding on nutrients that the tides bring up from below. With 2/3 of the tidal force gone, that mixing slowed down dramatically. The nutrients stayed deeper. The phytoplankton at the surface started running out of food. And everything that eats phytoplankton, which is essentially everything in the ocean, felt it immediately. Zooplankton populations began to thin out within days. Small fish that feed on zooplankton started migrating to find better waters. The larger fish followed. The entire food chain didn't collapse. Not yet, but it shifted. It lurched sideways, like a building that's still standing, but no longer sits on its foundation. Coastal ecosystems were hit even harder. Salt marshes, those flat, grassy wetlands that sit right at the boundary between land and sea, depend entirely on the rhythm of tides. They flood at high tide, they drain at low tide. That cycle is what keeps them alive. It brings in nutrients, it flushes out waste. It creates the specific salinity gradients that the organisms living there have adapted to over millions of years. With the tides reduced to 1/3 of their former range, salt marshes around the world started drying out at the edges. The water wasn't reaching far enough inland anymore. Grasses that had been submerged twice a day for as long as anyone could remember were now sitting in dry mud. Mangrove forests, which are the tropical equivalent of salt marshes, faced the same problem. Mangroves are anchored in tidal zones. Their roots are designed to be flooded and exposed in a daily rhythm. They filter sediment. They protect coastlines from storms. They serve as nurseries for hundreds of fish species. A mangrove forest without proper tides is like a lung that can only half inflate. It still works, but it's dying. And then there were the estuaries, places where rivers meet the sea. Estuaries are some of the most productive ecosystems on the planet, precisely because tides create a constant mixing of fresh and salt water. That mixing zone is where nutrients concentrate, where fish spawn, where birds feed. The Chesapeake Bay, the Thames Estuary, the Ganges Delta, all of them depend on tidal flushing to stay healthy. Without it, they begin to stagnate. Sediment builds up. Oxygen levels drop. Dead zones form. Not in years, in weeks. By day 5, the economic picture was becoming clear. The global fishing industry employs roughly 260 million people. 260 million. Coastal tourism, shipping, port operations, all of it was built on a planet with predictable tides. Insurance companies were the first to react. They started flagging every coastal property, every port, every marine infrastructure asset as high risk, not because of a flood or a storm, but because the fundamental operating conditions of the coastline had changed, and nobody could predict what that meant. The stock market did open, by the way. It dropped 9% in the first 2 days and then stabilized, mostly because nobody knew what to sell. This wasn't a war, a pandemic, or a financial crisis. It was a category of event that didn't have a playbook. Analysts went on television and said things like unprecedented and uncharted territory, which are just professional ways of saying we have absolutely no idea what happens next. I remember walking to the grocery store on day 6 and noticing that the bottled water aisle was half empty. Not because there was a water shortage. There wasn't. But people were scared, and scared people buy water. It's almost a reflex at this point. Something bad happens, you grab a case of water and some canned goods, even if the bad thing is 240,000 miles away, or rather, used to be 240,000 miles away. That first week, I also started paying attention to something I hadn't thought about before: the night. Every night, I would go out to my balcony, the same spot where I'd first noticed the moon was gone, and I would look up, and every night, the sky was breathtaking. Without the moon washing out the fainter stars, the night sky was transformed. The Milky Way wasn't just a faint smudge anymore. It was a river of light, dense and textured, with dark lanes of dust clearly visible to the naked eye. I could see the Andromeda Galaxy as a tiny, fuzzy patch without binoculars. Stars I'd never known existed were suddenly obvious. There was something deeply strange about that. The most beautiful night sky in human memory, and it was a symptom of catastrophe. Like flowers growing out of a crack in a collapsed building. You could appreciate it, but you couldn't forget what it meant. 1 month in, the world had more or less adjusted to the immediate shock. The moon was gone. Nobody knew why. Life went on, but differently. Coastal cities were spending billions reinforcing infrastructure that had been designed for a tidal range that no longer existed. Fishing fleets were being redeployed to follow fish populations that were migrating to new feeding grounds. Scientists were publishing papers at a frantic pace, trying to model what would happen next. And the models were not reassuring, because the next phase wasn't about tides or fish or dark skies. The next phase was about something much bigger. Something that operates on a scale so large that most people had never even heard of it. The moon has been slowly breaking Earth's rotation for 4.5 billion years. Right now, today, in our actual reality where the moon still exists, Earth's day is getting longer by about 2.3 milliseconds every century. That doesn't sound like anything. It's not something you'd notice in a lifetime, or even in 1,000 lifetimes. But over geological time, it's enormous. When Earth first formed, a day was only about 6 hours long. The moon's gravity, pulling on the oceans, creating friction against the spinning planet, has been gradually slowing that rotation down for eons. That's why our day is 24 hours now instead of 6. Without the moon, that braking force is gone. Earth's rotation would stop slowing down. The day would freeze at its current length, more or less, with only the sun's much weaker tidal effect still operating. On the surface, that sounds almost like a good thing. No more change, right? Stability. But here's the problem. The entire climate system, every ocean current, every wind pattern, every weather cycle on this planet has been calibrated to a rotation that has been gradually changing for billions of years. Stop the change, and you're not preserving the system, you're disrupting it. Ocean currents are driven by 3 things: wind, temperature differences, and the Coriolis effect, which is a consequence of Earth's rotation. The Gulf Stream, which carries warm water from the tropics up to northern Europe and keeps places like London and Oslo significantly warmer than they should be at their latitudes, exists because of a specific balance between all 3. Change the tidal forces that help drive thermohaline circulation, and you change that balance. Not overnight, not in a week, but over months and years, the currents begin to drift. Literally. 6 months after the moon disappeared, weather stations in northern Europe started recording temperature anomalies. Not huge ones. Half a degree here, a degree there, but consistent. Always in the same direction. Slightly cooler. The Gulf Stream wasn't failing, but it was weakening. The tidal mixing that had been helping to drive deep water circulation in the North Atlantic was diminished, and the current was losing momentum. Slowly, imperceptibly, but measurably. If you want to know what happens when a major ocean current weakens, look at what happened during the last ice age. The Atlantic meridional overturning circulation slowed down, and Europe's temperature dropped by several degrees in a matter of decades. We weren't there yet, not even close, but the trend was pointing in a direction that made climate scientists very, very uncomfortable. Meanwhile, something else was happening. Something that wouldn't become visible for years, but that the models were already screaming about. Earth's axial tilt, the 23.4-degree lean that gives us seasons, was beginning to drift. See, the moon doesn't just pull on the oceans. It pulls on the entire planet. And one of the things that pull does is stabilize the angle at which Earth tilts relative to its orbit around the Sun. Think of it like a gyroscope. A spinning top wobbles less when it's spinning fast, and the moon acts as an additional stabilizer, keeping that wobble within a narrow range, between about 22.1 and 24.5 degrees over a cycle of roughly 26,000 years. That's a tiny variation, small enough that seasons stay roughly the same shape, century after century, millennium after millennium. Without the moon, the stabilizer is gone. Earth is still spinning, still tilted, but now it's a gyroscope with nobody holding the base. And the other planets, particularly Jupiter with its enormous gravitational pull, start to matter more. Their subtle tugs, which the moon used to counteract, begin to accumulate. The models showed that over tens of thousands of years, Earth's tilt could swing anywhere between 10 and 45 degrees. Some simulations pushed it as high as 85 degrees over millions of years. Leave a comment and tell me, at what point in this timeline would you start to truly panic? The first night? The first week? Or right here, when you realize the planet's seasons are on a timer that just started counting down? I'll be honest, this is where the story changes. Everything up to now, the tides, the animals, the currents, that's disruption. What comes next is transformation. The kind that makes Earth unrecognizable. Let's jump forward. Not days or months this time, thousands of years. Because what happens next doesn't happen on a human timescale. It happens on Earth's timescale. And Earth is patient. For the first few centuries after the moon disappeared, most people wouldn't notice the axial tilt changing. It would drift slowly, maybe a fraction of a degree per century at first. Seasons would feel slightly off, the way a song sounds slightly off when it's played a half step lower. Summer might run a few days longer. Winter might bite a little harder. But nothing that would make headlines. Nothing that would make you look up and think about the moon. But the drift wouldn't stop. It would accelerate. Because here's the thing about gravitational stability. It's not linear. It's more like a ball sitting in a shallow bowl. The moon was the curve of the bowl, keeping Earth's tilt from rolling too far in any direction. Without the ball doesn't just roll a little, it wanders. And once it starts wandering, every small push from Jupiter, from Saturn, from the Sun, adds up instead of being corrected. 1,000 years in, Earth's axial tilt might have shifted from 23 degrees to 25 or 26. That sounds small. It's not. The difference between 23 and 26 degrees of tilt is the difference between the climate we have and a climate where the Arctic Circle extends hundreds of miles further south, where summer in northern Canada looks more like summer in Minnesota, where the Sahara Desert pushes its boundaries north into what used to be Mediterranean farmland. Entire agricultural systems that feed billions of people would be operating outside the conditions they were designed for. 5,000 years in, the tilt could reach 30 degrees. At 30 degrees, the Arctic and Antarctic circles move dramatically. Regions that haven't seen direct overhead sunlight in all of recorded human history would suddenly experience it. The ice caps, already stressed by centuries of shifting climate patterns, would begin to respond. Not melt entirely, not at first, but restructure. Ice that had been stable for hundreds of thousands of years would start flowing in new directions, cracking, calving, rearranging itself in response to a sun angle that the planet hadn't experienced since long before humans existed. The seasons at 30 degrees of tilt would be extreme by our standards. Summers would be hotter. Winters would be colder. The temperature swing between July and January in a place like Chicago or Moscow would increase by several degrees. That might not sound catastrophic, but agriculture is built on predictability. Farmers don't just need warm weather. They need warm weather at the right time for the right duration with the right amount of rainfall. Shift the seasons by even a few weeks, change the temperature curve by even a few degrees, and crops that have been bred for specific conditions over thousands of years start to fail. Not everywhere at once, but enough to matter. 10,000 years in, the models diverge. Some show the tilt stabilizing around 35 degrees for a while, held in place by a temporary resonance with Jupiter's orbital period. Others show it continuing to climb. The range of possibilities is wide, because we're now in territory where small changes in initial conditions lead to vastly different outcomes. This is chaos theory applied to an entire planet. The butterfly effect, except the butterfly is the mass of the moon, and the hurricane is the future of all terrestrial life. But let's take one path. Let's say the tilt hits 40 degrees after about 50,000 years. 40 degrees. At 40 degrees of axial tilt, Earth would be almost unrecognizable. The poles would experience months of continuous sunlight, followed by months of complete darkness, far more extreme than what we see today. The tropics, which currently experience relatively mild seasonal variation, would swing between blistering heat and surprising cold. The concept of a temperate zone, that comfortable band between the tropics and the poles where most of humanity lives, where most of our food grows, where most of our cities are built, would essentially cease to exist. There would be no moderate middle ground, just extremes. Rainfall patterns would be completely restructured. The Hadley cells, those massive atmospheric circulation patterns that determine where deserts form and where rainforests grow, are driven by temperature differences between the equator and the poles. Change the tilt, and you change those temperature differences. Change those differences, and you move the deserts. The Sahara might shift to where Europe is. The Amazon basin might dry out. New rainforests might appear in places that are currently tundra. The map of habitable land on Earth would be redrawn, and it would keep being redrawn because the tilt wouldn't stop. It would keep drifting, keep oscillating, driven by the competing poles of Jupiter and the Sun with no moon to referee. Now let's go further. 100,000 years, 1,000,000 years. At these timescales, some simulations from the early 1990s by French astronomer Jacques Lascar showed that Earth's tilt could potentially reach as high as 85 degrees. 85. That's almost sideways. That's Uranus territory. Uranus is tilted at about 98 degrees, and it essentially rolls around the Sun on its side. At 85 degrees, Earth would too. The North Pole would spend half the year pointed almost directly at the Sun, baking in continuous daylight, while the South Pole sat in perpetual darkness. Then they'd switch. 6 months of day followed by 6 months of night, everywhere on the planet. More recent research has pushed back on the 85-degree extreme. Studies suggest that even without the Moon, Earth's tilt might stay relatively stable for hundreds of millions of years, held in check by subtle gravitational interactions that Lascar's original models didn't fully account for. But even the optimistic models agree on one thing. Without the Moon, Earth's tilt becomes unpredictable. It might stay at 30 degrees for 1,000,000 years and then lurch to 50 in a few thousand. The stability that has allowed complex life to evolve, the stability that gave us reliable seasons and predictable climate zones for hundreds of millions of years, that stability is a gift from the Moon. And without it, Earth becomes a gambler, a planet rolling dice with its own climate, over and over, forever. Let me bring this back to something human, because it's easy to lose yourself in millions of years and degrees of tilt and forget what this actually means. It means that every civilization, every city, Every farm, every forest that exists on this planet exists because the moon kept the ground steady under its feet. The Roman Empire grew wheat in North Africa because the climate was stable enough for agriculture. The Industrial Revolution happened in England because the seasons were predictable enough for long-term planning. You are watching this video right now because 4.5 billion years ago, a Mars-sized object slammed into the early Earth and the debris coalesced into a moon that has been quietly, invisibly, thanklessly keeping this planet livable ever since. I stepped back out onto my balcony. It's been a year now in this thought experiment. The night sky is still beautiful, more beautiful than it ever was with the moon. The Milky Way is still there, still stunning, still detailed beyond belief. But now when I look at it, I don't feel wonder. I feel exposed. Like the roof has been taken off my house and I can see the sky. Yes, it's gorgeous. But I'm also standing in the rain. The ocean sounds different now. I live close enough to the coast to hear it on quiet nights, and the rhythm has changed. It used to have this deep, slow pulse. High tide, low tide, high tide, low tide. A heartbeat. Now it's shallower, flatter. The water still moves. The sun still pulls on it. But it's like listening to a heart that's lost half its strength, still beating. But you know something is wrong. The animals adjusted faster than we did, honestly. The ones that survived, anyway. Birds found new migration patterns within a few generations. Predators and prey renegotiated their schedules in the permanent darkness of moonless nights. Evolution is relentless. It doesn't mourn, it just adapts. But it adapts to whatever conditions exist, not to conditions that are good for the previous tenants. The new ecosystems emerging on a moonless Earth would be functional. They just wouldn't be built for us. That's the part that haunts me. Not the tides, not the tilt, not the ice caps. It's the realization of how thin the line is. How much of what we take for granted, seasons, stable coastlines, navigable oceans, a sky that looks the same from one century to the next, all of it depends on a rock. A big, dumb, beautiful rock that we write songs about and hang in mobiles over babies' cribs and use as a metaphor for impossible things. Fly Me to the Moon, Moonlight Sonata, Once in a Blue Moon. We named our months after it. The word month comes from moon. Monday is Moon's Day. Lunatic comes from Luna because people once believed the full moon could drive you mad. The moon is so deeply woven into human language, human culture, human identity, that removing it wouldn't just change the planet. It would change what it means to be a person on this planet. But here's the thing that I keep coming back to, standing on this balcony, looking at a sky that's too dark and too beautiful at the same time. The moon is still there. Right now, tonight, it's still up there, 238,000 miles away, slowly drifting outward at about 3.8 centimeters per year, doing what it's been doing for 4.5 billion years, pulling on the water, steadying the tilt, slowing the spin, lighting up the night just enough for the owls to hunt and the corals to spawn and the beetles to find their way. We didn't put it there. We can't replace it. We barely even think about it. It's the most important object in our sky, and most of us can't remember the last time we actually looked at it. So here's what I want you to do. Tonight, if it's clear, go outside, find the moon, and just look at it for a minute. Not to take a picture, not to post it anywhere. Just look at it and know what it's doing for you right now, in this moment. Holding the oceans in rhythm, keeping the axis steady, giving the night just enough light to see by. It's been doing that since before there were eyes to see it, and if we're lucky, it will keep doing it long after we're gone. Thanks for sticking with me through this one. If you made it to the end, you're exactly the kind of person this channel is for. Drop a like if this changed how you think about the moon, even a little, and I'll see you in the next one.